Hello everyone, and welcome to the webinar Education Using Robotic Telescopes. My name is Anastasia Boyko. I'm Project Officer at European SchoolNet and the coordinator of Educators Continuing Professional Development in spaceEU project. So I will be moderating this session today. Together with me, we have in the room my colleague Bjorn under tech support, who will be supporting this webinar technically, and of course the speaker for today, Edward Gomez. Just a bit of intro why we are doing this webinar. This webinar is organized for you, the participants of the massive online open course, Our Fragile Planet, that is currently taking place on the UN Academy platform. And the course is produced within the spaceEU project, a space outreach and education program that aims at motivating and encouraging young people to choose space-related careers, and which uses the perspective of space and the universe to broaden educators' knowledge of these topics. So our presenter for this session is Edward Gomez, Education Director at Las Cumbres Observatory. Edward has 15 years of experience working in astronomy education and outreach, and he has created many education resources, which he will share, I'm sure, with you today. Just a bit about the format of today's webinar. The presentation will last 45 minutes, and at the end of the session, we will have some time for questions and answers to address your questions to our presenter. So please share your questions, comments, and suggestions in the chat. You can find the chat tab on the right side at the bottom of the screen. We will dedicate about 15 minutes to your questions, and we will be monitoring the chat to collect your questions to address them in the end. So in case you encounter any technical problem during the presentation, please write in the chat, and my colleague Bjorn will support you. And now, after this short introduction, I'm leaving the floor to Edward. Welcome, and thank you for joining us. Today, we are very happy to welcome you and your presentation in our webinar.
Thank you very much.
I'm going to stop sharing the camera. Yes, and I'm going to stop sharing and you can go ahead with sharing your screen.
Hello, everybody. Yes, thank you very much for that introduction, Anastasia. I'm delighted to be speaking to you all today. I'm just going to share my screen and start my presentation. Hopefully, yes, you can see my screen and hopefully you can see me as well. Yes, I work for Las Cumbres Observatory. I'm the education director, as Anastasia said, and I manage the educational programs and all of the educational use of the Robotic Telescope Network. We currently have 25 telescopes in our Robotic Telescope Network. These are primarily used by professional astronomers making discoveries about the universe every day. These are robotic and autonomous, so there is no operator at any of these sites. The observations are taken by the telescopes independent of any intervention by a human. Astronomers log onto our website, submit their request, and it's instantly handled by our robotic scheduler, which packs together all of the requests from many thousands of users all around the world and sends them to the most appropriate telescope. It does this continuously and handles up to 10,000 requests at any one time, looking at a 2-week period. So it's quite a feat of software engineering to produce that, and a feat of electrical and mechanical engineering to create all of these 25 robots distributed around the world at professional astronomical observatory sites that you can see in the map in front of you. We also have a long-standing relationship with educators all over the world to use our smaller telescopes, our 40-centimeter telescopes, which are the 40 centimeters corresponds to the size of the primary mirror. So if you're Star Wars fans, they're about the same size as R2-D2, the little 3-wheeled robot in that. So we have two distinct components to our education program. the Global Sky Partners and resource development. I'll start off with the Global Sky Partners. These are groups of educators that manage their own well-constructed, directed projects with particular educational goals. They all use the 40-centimeter telescopes, but they all use them for totally different projects. Each year we have an annual call for proposals, and we have up to 1,300 hours available on our 40-centimeter telescopes. The projects will last for 12 months, and they're each assessed by an independent time allocation committee. So the proposals are not judged by me or by my colleagues, they're judged by 3 totally independent individuals who have expertise in astronomy and in astronomy education. In that link there, you can read more about the program itself and the partners, but I'll tell you a little bit more about it now as well. What we provide is we provide educational resources. I'll tell you more about those later. We provide observing resources, so how to get the best out of the data that you acquire, how to acquire your data, and we also provide advice and technical support on constructing your programs. We also facilitate the community, which is incredibly important. This group of Global Sky Partners are the people who lead these projects. Each partnership has administrators, or as we call them, principal investigators, and they are responsible for managing their user base. In some situations, there are only a few dozen of their audience, and in some cases, there are over 2,000. So each partner has a very, very different size of audience and very different educational goals. But all of these administrators or project leaders come together once a month, and we all talk about the problems that affect all of us, and they all have a self-supporting community, which is really, really valuable. So a little bit about the partner projects. We have, so the blue is for 2018, the green is 2019, and the orange is 2020. So the orange partners are currently doing their programs as we speak. Originally, we had a lot in North America and not so many in the rest of the world. Now we're gradually getting more and more in other countries as well. I'm very pleased to see more in the Caribbean and Latin America and Africa and the Middle East. But we also have had a rise in programs which are global, so ones which are not territorial. They have a remit to larger areas and many more people. And some of these are citizen science projects or distance learning projects. So these are the topics that these partners cover: student and teacher research projects. So this can be where either students or teachers, or students and teachers in partnership, do an investigation using our robotic telescopes and using the educational resources that the Global Sky Partner provides. Global observing campaigns, so this could be something that's topical. We've had people who are looking at Jupiter's moons over a period of time to use that as a pedagogical exemplary data set, and then created educational resources around that. But you could imagine ones that were topical around Betelgeuse dimming. We regularly have time series analysis. So if there's a particular some astronomical object which is varying over minutes, days, weeks, Las Cumbres Observatory is ideal for sorting out that type of observation campaign. Astronomy training programs. We don't allow partners to be from Western universities because we want our program and our telescope use to be put to the maximal effect. But we do allow applications for partners from the developing world where they don't have the same sort of resources as we do in Western places and more developed places. And so there are partners who are particularly concerned with training the next generation of science leaders. So people who are doing degrees, people are even postgraduates in astronomy and physics. We have citizen science projects. One of them was on the Zooniverse platform, if you've heard of that. The Galaxy Zoo is the famous Zooniverse project. The program that was using the Zooniverse was looking at gravitational wave, optical or electromagnetic counterparts. And we also have another citizen science project, which I'll talk to you in a moment about. And also artistic and inclusive outreach projects. And I'll talk to you about some of those too. Each partner gets an entry on our Global Sky Partners page, and you can see more about each of them there. They're subdivided into region and the type of audience that they attract. So a little bit more about some of the partners. Where's the Flux is a community project to study Tabby's star, which was quite famous because it originally was thought to be an exoplanet, but it appears to have very strange dips in its light curve when it was analyzed by Tabitha Boyajian. This has now become an observing campaign with a community that's self-supporting on Reddit or on subreddit. And this is what the subreddit looks like. Tabby Boyajian manages all of and some of her colleagues manage all of the communication through this, not through email, not through a forum, but through subreddit. So it's all in the public domain. And any one of you can join this and see the latest developments of Tabby Star, although I think Tabby Star is behind the sun at the moment. It may be familiar to you. The press picked up on it and called it, said that the reason that it had such a strange light curve was because of alien megastructures. So that's where it attracted a lot of media attention. Tactile Universe is a very, very different project. Tactile Universe is based in the UK, and its target audience is blind and visually impaired students at school. They take 3D models of astronomical objects in and teach the students about astronomy, something which is a very, very visual science. But they do this through 3D printed models. And we worked with the Tactile Universe, a project called Tactile Observatory, to produce 3D models of astronomical objects, which they use in their program. This is the Ring Nebula here that we printed actually on the 3D printer in our office. And this is a 3D print of the moon. The Tactile Observatory team have produced a pipeline which you can pass through any image that you take, and it will create a file that you can use to 3D print that. Another inclusive and artistic project is the Appalachian Star Song project. And this is a series of workshops where students were taught about time series astronomy. So the idea of making astronomical measurements, then calibrating them and plotting how the brightness changes with time. Now, students did this and plotted the changes of various different variable stars, and then sonified it using a web application. And so they turned this data set into not only a musical melody, but they also harmonized it as well. Apologies, this will probably sound terrible because it's coming out of my speakers and then back into the microphone, but let's give it a go. So a variable star has never sounded so good to me anyway. And this is the actual students' the students' work here. So the little doodles and joyful is what inspired her to harmonize it in that particular way. The achievements during 2019 were, so some of the projects that I haven't told you about are focused on mentoring high school and middle school students, so students who are up to the age of 18, to produce publication quality science investigations and then write them up to be peer reviewed. 28 papers were published in 2019. And those were by a number of different Global Sky Partners. The Global Sky Partners, their audiences followed up observations for TESS, which is an exoplanet satellite, Gaia, and the Minor Planet Center, which is looking at near-Earth asteroids. Students presented their findings at international professional conferences. So these are high school students, remember, and they're presenting their work alongside professional astronomers at international conferences. There have been state and county science fair winners in the US, a number of which were successful in getting college sponsorship to go on to university, which is phenomenal. And many tens of teacher workshops took place, and they used LCO resources and LCO data. These are some examples of the publications that students published in the Journal of Double Star Observations. These are, and the students' names are the ones that are first, and the last three names on each of the papers are the mentors. And here are some of the students. The ones on the left are students in a community college in the US who did research projects, and on the right are undergraduates and postgraduates for the Astrolab project, which was mentoring undergraduates and postgraduates in sub-Saharan African countries using Las Cumbres Observatory. That's quite a unique project because those universities don't have astronomical equipment themselves, and so by providing them robotic telescopes that they use over the internet, they have access to that unique resource, something that they normally wouldn't have any access to at all. And here are two students on the left and at the top right who are presenting their work at one at an IAU symposium and one at a NASA conference. Again, these are professional astronomy conferences. And then one at the bottom right was a state of Hawaii science fair winner. He's very proud of his rosette there. His project was to monitor the Tesla that Elon Musk sent up into space, and he was using our telescopes to monitor that. And he called it Fast Car High Mileage, which I think was quite amusing. The audience size of the whole program, that's all of the Global Sky partners, we reckon to be around 13,000. That's the direct audience, people that our partners were in contact with. And the indirect, so the audience that we had an effect on, because many of the direct audience were teachers, and so adding their students into the impact figure, we think is around 27,000, which is quite impressive. I'm very pleased to say that next Monday, we will be issuing a call for new Global Sky partners. And this would be something that I would very much welcome a group from spaceEU to submit a proposal for using the Las Cumbres Observatory. Okay, so that's the Global Sky partners. Remember I said there were two aspects of the work that we do at Las Cumbres Observatory. I've given you a more open-ended, our more open-ended programs. Now the educational resources which are supplementing curriculum and have very fixed endpoints. The first I'm going to tell you about is not using robotic telescopes, but is still related. Ada's Adventures in Science is a series of science comic books that I wrote with an illustrator. It follows the life of Ada. She starts off in junior school, moves up to high school, and eventually becomes a postgraduate studying astrophysics. And the idea behind this comic book is all about inclusion. The idea that kids can do science. They might not think that they're very good at science, but they can do it because they can ask questions, no matter what their background is, what's going on in their home life, where they live. They can all ask questions. And until the age of, when they're in elementary school, they're fantastic at asking questions. And when they get to high school, they stop asking questions. And that's something which is mystifying to me as a scientist, because that's what drives science, is the thirst for knowledge, the idea that everything that we've learned could be wrong. So you always have to question it. And so that's the reason that I created these comic books, is to try and inspire kids, try and stop kids from this idea that asking questions isn't cool any longer, and not caring about the answers, just taking that that what you're told at school is the right answer, and actually it could be the wrong answer. Just because it's written in a textbook doesn't make it right. So the three comic books are about asking questions, about making measurements and refining your ideas, and the final one is about working together. You can find all of the comic books at that web address. We have them in English, in German, in Spanish, in Mongolian. If anybody speaks Mongolian that's on the call, and Welsh, because I'm based in Wales in the UK. I very much hope to have a Portuguese version soon, but it would be great if you think that you could assist in the translation of these, then that would be amazing. They are all Creative Commons licensed, so please print them off and use them with your students. They're particularly, we made sure that they were black and white, so you didn't have to worry about color printing as well. They've been used in Ireland, Mongolia. This is the bottom left is Nigeria, and the bottom right is Pakistan. Okay, moving on. We developed an open source astronomy textbook, which is called Spacebook. It is the most popular resource that we have on our website. This page alone, Parallax and Distance, attracts 600,000 hits a year, unique hits. So we realized that this is an incredibly valuable resource, and we've added videos and paid extra attention to the illustrations that we've included on each of these pages. This is the Parallax page, and I'll just briefly show you the video from that.
Have you ever traveled down a road in a car and looked at the mountains or hills in the distance? If you have, you've probably noticed that while nearby trees quickly fly past the window, the mountains move much slower, and in the far distance, the moon and the stars.
So I'll just cut it off there. But we were very careful with each of our videos that there's very little text on the screen. The reason for that is all of the videos are available on YouTube, and YouTube you can have closed captions or subtitles. And then we realized that if we put text on the screen, it can't be translated terribly easily, but subtitles can. And so Google does actually a pretty good job of transcribing and automatically translating the audio content of videos. So all of those are freely available. Another free resource is our activities. We have over 30 activities on our website that supplement all of the education programs that we currently support. You'll see the very first one there is about parallax. We also have activities about things that parallel our research topics. Because we're a very responsive observatory, we can take observations very, very quickly because we're autonomous and robotic. Time domain astrophysics is what our majority of our researchers are interested in. So this is phenomena that are changing on a time period of minutes, days, and weeks, and things like supernovae, things like asteroids, and things like exoplanets. So you'll see those reflected in our activities. Each of our activities has an introduction, a background science section, and has an evaluation section, which is very important. Several of our activities were developed in conjunction with the Space Awareness Project, which is the forerunner or the sister project to spaceEU. So many of you may know, certainly Star in a Box was one of our very popular activities. I'll just tell you about that now. We developed Star in a Box because I found when I was doing school workshops that this was the part of the curriculum that the teachers found it the most difficult to find good resources to support. It was a subject which many teachers may not have covered in their studies, because not all teachers who teach physics are physicists. And if you're a chemist, you probably won't have come across, or a biologist or a geologist, you won't have come across the life cycle of a star. And we found that the textbooks that were available to schools often weren't quite right or had a lot of ambiguous information in them. So we came up with this online tool. I have an animation of it here for you. So this is the star for Star in a Box. So, yeah, there you go. You can see that it's a metal box. Obviously, you'd be crazy to put a star in a wooden box. This chart here is called the Hertzsprung-Russell diagram, and it's an incredibly useful plot for astronomers. It was we use it a lot to analyze where a star is in its life, and you can see you can see those white flashes are when I've selected stars which will eventually go supernova. You can play around the mass of the star and see what happens, and you can see the temperature change, the size change. You can see that this is a star 4 times the mass of the sun, and it does this looping back and forth as it goes through its what's called the asymptotic giant branch phase, and then it suffers something catastrophic, and then it just gradually fades away when it's a white dwarf. And there's information on each of those phases on the star there. We've made we also realize that textbooks only show often the simple picture of what the life of a star is like. And so we do present that simple picture, but we also present a more realistic picture, so you can flip between the simple mode and the advanced mode, because we were concerned that if students went straight to the advanced mode, they'd quote parts of the life cycle of a star, which maybe, I don't know what marking of school exams is like in other countries, but in the UK, there is a list of keywords, of buzzwords that students have to mention. And if you're a good student and you've read around the subject and you are familiar with talking about the subject and you don't mention the buzzwords, you don't get the marks, which I think is a crazily, absolutely abhorrent situation. It makes me very mad to think about it. But anyway, that's what governments do. Anyway, that's my rant over about that. So, Star in a Box. We have educational resources to support the use of this web app. So activities for you to use with your students and using in conjunction with this interactive web app. Agent Exoplanets. This is a project which came out of doing school workshops, where I was quite frustrated, as well as the teachers being quite frustrated, that it's difficult to install software on school computers. It's even if you plan ahead and you say, can we please have these things on a computer, it's then you have the frustration of getting caught up in learning how to use a piece of software for a workshop, and it doesn't really tell you about the science that you're trying to do. It teaches you how to use that software, and you actually may not use that software again in a different context. So Agent Exoplanet is about exoplanets, and particularly about how astronomers analyze the light from exoplanets with a technique called photometry. We made it inside a web browser and made it very, very simple. You place down little markers on top of the target star, the one that has the exoplanet going around it, and then calibration stars, as well as a patch of background sky. And you flip through each of the images in your time series, in your sequence, and the Agent Exoplanet system produces this graph for you. So it teaches students how to do the photometry without getting caught up in the mechanics of using AstroImage-J or Salsa-J or even DS9, the professional tools. Now, once you've mastered the idea, the concepts behind what you're trying to do, then you can move on to using those tools if you wanted to do your own investigation. The answers to these investigations are known already. These are exoplanets that have been studied at length by other researchers. But all of this data is open source data that was taken by Las Cumbres Observatory. And based on your measurements and combined with other measurements by anyone else using ancient exoplanets, you get to see the properties of the stellar system, that's the extrasolar planetary system that are derived from that graph. Okay. Now, those were resources that used astronomical data or used astronomical concepts, but didn't use the robotic telescopes themselves. That's good if you don't have an internet connection, or if you wanted something which only lasted half an hour. All of our robotic telescopes operate in a queue scheduling mode, so you can't drive any of our telescopes in remote control mode. That goes back to the efficiency that I was talking about right at the start. You imagine we've got many thousands of users. If you were to let all of them use the telescopes in remote control mode, you'd end up with a lot of disappointed users. So that's why we have this very efficient way of creating an observing schedule automatically. Now, how does that fit into our education? Well, first off, we wanted to have tools that were simple for that were fun, but also took out the again, looking at. I realized that teachers are time poor, and if you have to invest a lot of time into learning and observing interface, and you don't really know if this is going to fit into your curriculum or your lesson plans, then you're more than likely going to say, well, I'll do something else that I know will work each time. This is the concept that really inspired all of the things that I'm going to show you from this point on. Messier Bingo is an online tool. It teaches students through creative, through play, but it also teaches students about using astronomical vocabulary. So I hope you're all familiar with the game of bingo, where normally you have a sheet which has a grid of numbers and you have to wait for the tombola to produce different numbers. In this case, instead of numbers, we have catalog numbers, the Messier catalog. In particular, there are 110 objects in the Messier catalog. The chap that you can see up in the top left corner was Charles Messier, who was a French astronomer. He was living in Paris, and he desperately wanted to be famous. And so he looked every night with his telescope at the night sky in the 19th century and was looking for comets, because at that time, and actually now, you get to, if you discover a comet, you get to name the comet after whatever you want, but normally people name them after themselves. And so he wanted to be famous. He was very interested in comets. And every time he went out, he would look for things that looked fuzzy. And he kept a log of things which didn't move in the sky, things that weren't comets, because those were boring to him. And this catalog has 110 objects in it now. It is a very nice list of objects that cover all of the different types of objects, or the majority of types of object that you'll find out in space. And so this is a very good starting point if you want to introduce things like galaxies, globular clusters, planetary nebulae, star-forming nebulae, and things like that. So along with this, you can download bingo cards, which have a random selection of 12 of the objects that you'll see in the tombola. Each time you load the tombola, you get a random order of that 110 objects. And this is just a little screencast I made of how it works. So you can see the address there. So there's a link there to where you download the bingo cards from. And so I'm just clicking the login button. Now, if you can just play it without needing to log in. If you log in, you get some extra features. Those as they appear. So you see that there's a nice astronomical image, and you can flick through these. Each of the observations has a description, a catalog number, and also the person who took it. You also have this special feature that if you like the image, you can take a picture of it with Las Cumbres Observatory. And there you go. As simple as that. Single click, I want a picture of that. And there's a link at the top that takes you to the observing portal, and you don't have to fill in any of these details, and that request has already been logged with our scheduler. So, taking you back to the tombola now, and you carry on playing your game, and you could click on these with your class. You could say, oh, who likes this image? Does anyone have M19 on their bingo card? Yes, okay, mark it off. Okay, we'll take a picture of that, and it'll be ready sometime in the next week, and you get an email when it's done. So that's the simplest way that you could use Las Cumbres Observatory to make observations, or you could just enjoy the images that other people have made. The next advancement in using LCO is via Kiosk. Kiosk is an extremely simple observing interface. So the link that I showed you previously took you to our full observing interface, which is open to astronomers, educators alike. Kiosk is a pared down version. You can see that under select a target, there's planet, galaxy, star cluster, nebula. And if you click on each of those, you get a selection of objects that you can choose from. You don't have to know the catalog names. You can play Messier Bingo, and you can see there that there's an M82, which would have come up in Messier Bingo. In fact, I think it may have been the first object we saw. And again, you click on that, and you click Submit, and you're done. Everything else is sorted out for you. But unlike Messier Bingo, you can also see your past observations here, and you can see a beautiful color image of each of them there. So in the list of objects on the right-hand side, you can click on the Get Image next to each of them, and the status with the tick says that each of those has been observed, and when you click on them, you can see a beautiful 3-color image has been created. You can also download that image with the download button at high resolution, or if you click on the name of the object, in this case the image is of a spiral galaxy called M100, and you click on that, it'll take you to the main observing portal. So you can download the astronomical data from there if you wanted to use one of our activities and produce your own color image. And finally, the last activity, or the last suite of resources that I would like to tell you about, is Saral. I'm based in Wales, and I'm Welsh myself. I do speak a little bit of Welsh. So when it came to naming the robotic brain behind Las Cumbres Observatory, I thought a Welsh name would be appropriate. And Saral means starry or star-like. And so that's Saral there. Saral is just an algorithm, but when I'm talking to school kids, it's a lot easier to talk about Saral as being a robot that takes all of the observations from astronomers all around the world. This is the Saral website. You can see the address there. This is open to anybody, so you don't have to be a member of one of our global Sky partners. You can create an account for you and your students to learn about astronomical objects through this website. There's Saral there. Actually, on the real website, this is animated. So click on Start Your Adventure, and you'll be directed to either log in or register if you haven't already. There are 3 distinct missions. The aim of Saral is to, as you go through this, and you can go through this process with your students, you don't need to do it in advance. Each mission has challenges, and each challenge is about learning about a particular type of astronomical object. So the first mission that you have, Get to Know the Night Sky, has a broad scale selection of astronomical objects, and once you've completed that mission, you unlock mission 2 and 3, which is the life of stars and the universe at large. This is one of the challenges from mission 1. You click on Start the Challenge, you have a little bit about nebulae, so that you can put that in context, and then you get a selection, and if you click on each one of those names, you'll get a little bit of text about each one of those objects, and then Saral, you click submit, and Saral will go off and observe that for you in a similar way that we saw in Messier Bingo and Kiosk. You get to see where and when the observation will be taken. So you can sit, and you could sit in principle for 3 days. That's how when this observation will be taken. And you'll see fun facts appearing every 30 seconds. And you can see this is the Las Cumbres Observatory site is in Chile, is going to do this observation. But you can always come back to your account, and you'll either see the latest status on this page, or it will forward you to prompt you to do more investigation. So once your image has been taken, and there's our beautiful image of Barnard 168 there, which is a nebula, you'll actually be taken through some steps before you get to this stage of analyzing the image. So you'll be asked things about, you can see the questions there. What color is the gas? Are all gases the same color? What's the shape of the nebula? Can you see stars amongst the nebula? So you do perform a little bit more analysis as you look at the image with your students there. And then you can move on to the next challenge, which presents a different astronomical object. You get stickers for each one. You can see that there's a nebula sticker there, and you can see at any point the stickers that you've acquired in each mission. We also have, to support this, a series of short films about Saral and about Las Cumbres Observatory. The very first one, The Hunt for Dark Skies, really motivates why we have a network of telescopes and why Saral is a robot that automatically schedules them instead of having a person scheduling each telescope. And then we have a video about Saral and the Sick Star. I won't tell you how the star is sick, and Saral and a cosmic visitor, which is about solar system phenomena. So those are all animated, narrated videos that you can enjoy as part of this.
The night goes on, and Saral's team are hard at work. As one telescope closes for the day, another wakes up and takes over. More pictures flow in until Saral grows confident it knows what the mystery object is. The survey telescope has spotted an asteroid. Asteroids are chunks of ice, rock, and metal left over from when the planets in our solar system formed.
So there you go. That gives you a taste of, I hope that's not a spoiler. That gives you a taste of what one of the videos is like. We also have educational resources. So we have some lesson plans, but we also have things like coloring sheets, and you can build your own Saral with cardboard, or if you have a 3D printer, we have 3D printer models as well. You can also 3D print some telescopes as well. And we even have a video game. So you can do what Saral does and collect observations from astronomers and then send them to all the telescopes in this video game. And it has 3 levels, so you can see all the levels happening at once there. The videos and the video game you can play without needing to log in. So we thought that those were nice fillers if you wanted your students to look at this at home. And we also have a global network status as, in the Saral universe. You can see each of the observatories and all of the telescopes, whether they're awake, whether they're observing, or whether they're in daytime and so they're asleep. So we really wanted to make the Saral suite of resources feel like all of the, whenever you look at them, to feel like you're invested in this project, so that's why they have their own personalities. So that's the website for Saral. I would be delighted if you wanted to use this. Use our robotic telescopes as part of this. There are classroom resources, animated videos, and there's even an 8-bit inspired video game as part of it. So thank you very much for listening to me for all of this time. I really hope that some of those will be useful to you, and I'd be very happy to answer any questions that you have. And I'd be especially delighted if you wanted to put together a proposal for becoming a Global Sky partner. I'll send Anastasia more details of that when we announce the call on Monday, and we can be in touch over that. I will stop sharing my screen.
Yes, thank you, Edward. That's perfect timing. And actually, you covered a lot of topics that we introduced in the MOOC for participants in Module 1 and 2. And that's actually, I'm addressing this call for participants. That's actually your moment, your time to address the questions, because Edward covered citizen science projects, all the resources, remote telescopes, and all these things that can help you with introducing astronomy in an engaging way to your students. Now, we are still waiting for some questions. I see thank you, a lot of teachers saying thank you for the presentation, but that's not yet time to say goodbye, because we have 15 minutes for answering the questions. If you have any of the questions, you can post them in the chat. Let us give them a couple of minutes. Meanwhile, maybe I can address my own question that I prepared for you. And you were so passionate about explaining about these resources, and I understand you invested a lot of time and skills of yours to creation of that resources. And when did you realize actually that you are interested in astronomy outreach?
Oh, that's I can almost pin that to a date. It was, I'll give away my age now. It was in 1997. I was a second year undergraduate student, no, a third year undergraduate student here in Cardiff University, actually. And I gave a public talk. I'd been reading about, so I found a book in the library that I actually have a copy of at home now, because I found it in a secondhand bookshop. I can't remember the title of it. It's something to do with views of the heavens or something, and it told different creation stories, and I was fascinated by how different cultures had thought about how creation happened, and so I gave a talk. It was actually I think in Science Week, which is in the UK is next week. So it's almost like it's the anniversary. It's the 23rd anniversary of my very first public talk. And so I gave a public talk, and it had something like 11 people in the audience. But at that point, I thought, actually, I'd really like to do this. And so when I was a postgraduate student, I found a program in the UK called Researchers in Residence, which gave some mentoring to postgraduate students to go into schools and to run projects. And I ran a project on sustainable energy in a couple of local high schools. And then I really saw the absolute importance of, as a professional scientist, to doing outreach, how there is a vital role that teachers fulfill, and there's a very complementary role that scientists can fulfill in going into a classroom and saying, what your teachers are saying, actually you should believe them in terms of the jobs that you'll get and the importance of mathematics. And I'm a living scientist, and this is what a scientist looks like. And I always encourage my colleagues to go out and go into schools and to show their faces, because I know a diverse group of people, and it's so important for students to think, actually, that's something I could do. It's not, it's not for, unfortunately, I'm now a middle-aged white man, so going into schools means that they see a middle-aged white man, and then I don't think school children need to see very many middle-aged white men. So I always try and encourage people who are from more diverse backgrounds, and obviously I support them in whatever way I can. That was a very long answer.
Yes, thank you very much. But the information that you got from your personal perspective, that's very important, and I think that's vital also for teachers to understand that they need to showcase real life role models and to have the diversity aspect in their classroom as well. And that's also a part of the material that we present in the online course. And that also goes in line with the project objectives. Thank you for sharing. This is I understand this is very personal story, but I think this is how people all around the world can understand that the things that we do locally, they are also important for education and for outreach of STEM subjects. So there is a question from Stefan. Which of these programs that you presented best fit primary and respectively secondary school? So which of those that you presented can fit to primary and to secondary?
That's an excellent question. Thank you, Stefan. So the Saral project, we created that particularly because we saw that there was a gap. Many astronomy outreach and educational projects are for high school students, and so Saral is particularly tailored to elementary primary school. You're probably talking about the last 3 years, so from the age of 9 up to 11 or 12, depending on your national variability, and maybe as low as 8, depending on how confident you are about not putting off your students. But the Saral project is very definitely primary and early secondary, late primary, early secondary school. Messier Bingo similarly. The Kiosk tool is really for you to use with whatever age group you feel comfortable with as the teacher, because you're going to be the driver there. Agent Exoplanets and Star in a Box are very definitely high school projects. The concepts are quite advanced in those, and the level of technical ability in those are more towards the I would think above 14, 15 year olds. The Spacebook is probably similar age, although Spacebook we've written with a public audience in mind. So it's the idea behind it is a space textbook for anybody, but it's probably more suitable for older teenagers and a general public, so people who are just general public interested in astronomy. A lot of our activities on the activities page also have, in fact, all of the activities have age ranges. So the actual activities, aside from the resources, the activities themselves have age ranges.
And also, Stefan says, yeah, exactly, for clarification.
Yeah. Global Sky. No, Global Sky Partners. We have projects which are entirely for primary school, and some that are more for secondary school. It's very much not for university students. We have 2 projects which are for university students, but only in the developing world, and their total audience is 100 students. The majority of our audiences for those are in secondary and primary, but the difference between the Global Sky Partners is that the partners come to us with a project idea with educational resources, and they say, we will support our audience and you bring us the telescope time. And so you can imagine if you've got activities that need astronomical data, that needs time, that you've used something from like a website, you've downloaded some data in the past, you could get real data for that project by becoming a Global Sky Partner.
So yeah, very interesting, and I think they will try Saral, and yeah, I'm also excited about the tool you presented, and I want to collect all the stickers already. So yeah, we'll be spending some time on that. Meanwhile, coming back to Ada's Adventures comic book, you said that there is an opportunity for teachers to contribute to translations. How it can be done, and maybe students also can contribute to that.
Yeah, it would be so. Because this is something that's been created by an artist, I can give you a text document, a Word document, which has all of the English in it and a space for putting the translation. And then I will get the artist to do the transcribing. And then we'd need you or a team of people who are, with a particular language skill that could check it over for us. And then we'd make it public on our website. It's an open source project, so it's the Mongolian one was amazing because it was Solman Renchin from Mongolia, and she said, "Yeah, she didn't even ask me for any of the translation files. She just said, oh, I've done this," and just presented me with a PDF of it in Mongolian. It was amazing. But we can help you with that because creating the print version is going to be quite difficult unless you've got graphic design skills, which you may. But we're happy to help with that. But yes, please be in touch. My contact details are on the final slide, but obviously Anastasia's
absolutely, and we will be sharing the slides and the recording of this webinar afterwards on the platform of the MOOC. So everyone who is listening now and who will be listening afterwards, after the session is done, and at the recording, we will also add slides with Edward contact. So you can contact him for the resources that presented today, and also for translations if you're interested in that. Now we have a bit of time for the last question that I put together before the session, actually thinking of what can be helpful for teachers and to get as a takeaway from this webinar. And then the question is, what advice do you have for our teachers, mainly teachers, but also in general educators and outreachers, for exploring astronomy themselves, and how they as educators can motivate pupils to study astronomy?
So don't be afraid to explore astronomy with your students. If you just want to take astronomy topics, and actually a very good place to start would be with the comic book, with Ada's Adventures, because you can maybe read the comic books in your classroom out loud and get each of your students to take on a different character, and then talk about the astronomical concepts or the scientists that are in the comic book, and talk about it as a round table discussion, as a whole class discussion, and start that way. I've met teachers in the past who've been afraid to take part in one of or to use one of our resources because they didn't know what the outcome was going to be, and they said they weren't willing to take the risk that something unexpected might happen while they were in front of the students. I'm not a teacher, so I have a very different perspective to you, and I understand that. But in my experience running workshops with students, the students often like it the best when something goes wrong or there's something unexpected, and that's because they're all little scientists. That's why. But if I would definitely recommend that you explore things together. Obviously, you'll want to prepare in advance, and that's I can totally understand that. But if you wanted to use Saral, for example, do it with your students. Don't go through the whole mechanism in advance beforehand and then present it to your students. Say, this is what we're going to do today. If it doesn't work, I mean, you're all experienced teachers, I'm sure. And so if something doesn't work, I'm sure you've had technical problems in the past and you know exactly what to do then. But if something doesn't work, you don't have an internet connection or the website breaks for some reason, I'm sure you can cope with that. But explore it together with your students and find out more about astronomy together. On the ADA website, adacomic.uk, there are some educational activities which I didn't mention, but please do have a look at them. One of them is about creating an alternative ending to one of the comic books, and one of them is about creating a poster. And that's, I always think, is a great research project that students can then do and be proud of. You can display your poster in your classroom.
All right, thank you very much. So it's actually time to wrap up our today's session. You done brilliant job of presenting, and participants done really good job with listening and staying with us for the whole presentation. Thank you again, Edward, for your time, and thanks for everyone for listening. So the recording of this webinar together with the slides will be available on the MOOC platform in Module 2. So please revisit this section to access the presented resources later on, to see the links, to try out things on your own. And before we finish the session, I thought it will be useful for our participants to be informed about one more live event. It's a Teach Meet that will happen on the 18th of March, and in which the teachers can participate as speakers actually. So they have to receive, they received today a course email, but also the information about this event is accessible in live events section on the platform. So please visit the live events on the MOOC platform and see what is coming next. So thank you again, Edward, and thanks all for taking part in the webinar. I hope you're enjoying the MOOC and the material presented today. Have a nice evening, all. Thank you very much. Bye-bye.
Thank you. Goodbye.